Today we're going to talk about rational word problems, and in order to do that, we're actually just going to do some of the questions that are on the worksheet that's posted on Google Classroom for you. So the first one we're going to talk about is number 4. This question is a lot like number 20 that was on the rational equations worksheet. So it says the denominator of a fraction is 2 less than its numerator. If the numerator is decreased by 1 and the denominator is increased by 5, the sum of the resulting fraction and the original fraction is equal to 2. Find the original fraction. Okay, so we have the original. We know that the denominator is 2 less than the numerator, so that would look like this. For our new fraction, the numerator is decreased by 1 and the denominator is increased by 5. So that means that our new fraction, or the resulting fraction, would be x minus 1 over x plus 3. Now, this tells us that if we take the original and the new, the sum of those, meaning if we add them together, is going to equal 2. All right, so we're going to get a common denominator between these two or actually all three of these fractions, and the common denominator would be these two pieces, okay? So the first fraction is missing the x plus 3, so that would give us x squared plus 3x. And the second fraction here is missing the x minus 2. So when we distribute those in combined like terms, we get x squared minus 3x plus 2. And over here, we're missing both the x minus 2 and the x plus 3. So multiplying these two pieces together, we get x squared plus x minus 6. And then we're going to distribute that 2 to each of those. So we would have 2x squared plus 2x minus 12. All right, so if we clean stuff up here, I notice we've got an x squared here, x squared here, so it's 2x squared, and that 2x squared would go away with each other. The x's go away there, makes a 0 pair. That means I'm going to move this 12 over, and we would have 14 equals 2x. Dividing by 2 on both sides, that tells us that x equals 7. The original question doesn't ask us what x is. It asks what the original fraction is. That means that we're going to plug this 7 in for these x's over here in the original fraction and see what happens. So we have 7 over 7 minus 2, which means that 7/5 is the original fraction for this question. Okay? The next type of question we're going to see is something like number 5. And number 5 says this: the sum of a number and its reciprocal equals 2, find the number. So we did questions like this actually back when we talked about quadratics, but you can also do them in this section as well. So a number, which we don't know what it is, the sum of that and its reciprocal, remember reciprocal just means we flip the fraction, equals 2. Okay, so in this case, our common denominator for all of these would be x. So the first fraction is missing x. So it's going to give us x squared. Second fraction isn't missing anything, so that's 1. And then the third fraction is also missing the x, so that would equal 2x. All right, we're going to get them in standard form here, so we're going to move those x's over by subtracting them. And now we have x squared minus 2x plus 1 equals 0, so we're able to factor this. We're going to factor it into x minus 1 and x minus 1. For this particular question, these two are the exact same binomial. Sometimes they will be and sometimes they won't. Since they are the same though, we only need to set one of them equal to 0, which means that x equals 1. In this case, x was the original or the number that we were looking for, so it does work. Okay, it's also something that you can, plug these things back in to make sure they actually do work as well as you're moving along. Okay. The next question we're going to look at is number 12. So I'm going to actually start 12 over here, and then we're going to kind of work our way around on the piece of paper. Okay, so number 12 says a plane with normal airspeed of 165 miles per hour flies 425 miles against a headwind and then returns with the same wind as a tailwind. If the outbound trip takes 1.2 times as long as the return, what is the wind speed? Okay, there's a lot of stuff happening there. We need to know that distance equals rate times time. Okay, that means that if we transform this equation for time, we would get distance divided by the rate is what the time is. We know the distance for this. We know the rate within reason, and then we know that one of the trips took 1.2 times as long as the other one. All right, so we're going to use this, setting them equal to time, to help us out. Now, we have an outbound trip, and then we have an inbound or a return trip. Okay, on the outbound trip, we're going to travel 425 miles. Now, with that, it's saying that we're traveling with a normal airspeed of 165 miles per hour against a headwind. If we're going, we don't know what that speed of the wind is. That's actually what they're asking us to find. But since we don't know what that is, it's going to be X. And since it's a headwind, is that going to make me go faster or slower? So it's going to make me go slower. So I'm going to subtract X from that 165. On our return trip, we're going back those same 425 miles. In this case, I have 165 miles an hour still, but it's a tailwind and it's actually helping me along. That means that it's going to increase my speed by whatever that wind speed happens to be. Okay? So our outbound trip, if we're doing distance divided by rate, we have 425 over 165 minus X. That's equal to the return trip, which is 425 miles divided by our rate, our speed of 165 plus X. Now, one of these the outbound trip takes 1.2 times as long as the return. That means that we need to multiply the 1.2 by the return. Okay, this one is slower, which means I need to take the faster one and multiply it by the 1.2. Okay, you need to take the faster one. This is the faster one because it's taking this wind or the speed of the plane and adding the wind to it. So it's making it go at a faster speed, which means you will get there in a shorter amount of time. Okay, this one is the slower because you're taking that speed of the plane and you're slowing it down. If you're going slower, you're going to take longer to go that same distance of 425 miles. All right, so now we are going to solve this. That means, I'm going to come over here with my work. That means we still have our 425 over 165 minus X. That 1.2, what does that actually get multiplied to? So it only gets multiplied to the 425. When you do that math, you get 510 over 165 plus X. Now what we have here is just a proportion to solve, okay? So we're going to cross multiply. So that means that we're going to take 425 times 165 plus X, and that's going to equal 510 times 165 minus X. Distributing in there, we get 70,125 plus 425X. That's going to equal 84,150 minus 510X. So I'm going to get the X's over to the left and my numbers over to the right, my constants. So I'm going to add 510 and we're going to subtract the 70,125, which means we would get 935X equals 14,025. And then to get x by itself, we're going to divide both sides by 935. And x would equal 15. Now, what is that rate, or what is the unit for that? So we got wind speed, and that would be in miles per hour. So I'm just going to say mph there. Okay, so the biggest struggle that people have with these questions is just which one to multiply the rate by. Here you're going to multiply it by the one that's going faster, so the one that's adding that speed to it. Okay. The next one we're going to look at is number 17. 17 here says a baseball player has 48 hits in 170 times at bat for a batting average of approximately 282. How many consecutive hits does the player need to raise the average to at least 300? Okay, so for this, we know that this baseball player has 48 hits out of 170 times at bat. Now, we want to know how many consecutive hits does the player need to raise their average to at least a 300. We don't care what their current batting average is at all, okay? But if we increase a hit, that means that we've also increased the same number of at-bats because it says consecutive hits. So if we're hitting it 3 more times here, that means that we would have 3 more at-bats that have happened. So it doesn't need to be plus X for both of those. All right, so again, we have a proportion here that we're going to solve. So we would get 48 plus X equals our 300, or just 3/10 here, in, I'll say, normal numbers, times the 170 plus X. We're going to distribute the 0.3, or 3/10 times 170 is 51. Getting our x's to the same side here, so when we move those over, we would get 7/10 x, and moving this over, we would get 3. Now, when we divide both sides by 7/10, we're going to get 4.28, and it's going to keep going on from there. With this, can you have 4.28 hits? Absolutely not. So we need to round this up to 5 hits. Okay. If we had 4 hits, that wouldn't be quite enough. All right. The last one we're going to quickly look at here is number 23. So all of these in this section from 21 to 25 are going to use the formula 1 over the first plus 1 over the second equals 1 over the total. Okay, and we're using this because, well, let's go over what the question is first, okay? A tank can be filled in 4 hours through 2 pipes when both are used. How many hours are required for each pipe to fill the tank alone if the smaller pipe requires 3 hours more than the larger one? So we're comparing each of the pipe's works, or 2 of the things, whatever they are, to 1 hour. That's why it's 1 out of the first. If the first can do it in 3 hours, then they can do 1/3 of the work in 1 hour. Okay, same thing here. So if we're looking at this, we have the big pipe can do it, okay, in X number of hours, and the small pipe can do it in 3 hours more. Okay, that means that since it's a smaller pipe, not as much is going to go through, and it takes 4 hours for them to work together on this. Okay, so for this, our common denominator is going to be 4x and x plus 3. So that means that the first fraction is missing 4 and the x plus 3. The second fraction is missing the 4 and the x. And the last fraction is missing the x and the x plus 3. Once you have this, you're going to go through and solve for what x equals.